Okay, so that was a long question, wasn't it? Now let's go to question 2. Chloride iodide again. Blah, blah, blah. There's some silver nitrate. Chloride, of course, goes to a white precipitate. Iodide produces a yellow precipitate with silver ions. This is GCSE type stuff as well. And then we're adding aqueous ammonia to the mixture and shook it. Well, as we've already mentioned in the previous question, when you have the silver chloride white precipitate, it dissolves with ammonia. The yellow precipitate from silver iodide does nothing with ammonia. And the reason for that is because ammonia likes to bond to silver and will do so if it can. Now, the silver iodide interaction bonds are too strong for the ammonia to break on in there, but when you've got the silver chloride interaction weak enough that the ammonia can pop on in, tell the chloride to get lost and complex to the silver ions, giving you this nice soluble ammonium silver or ammonia silver chloride. Doesn't happen with the iodide. So many fire-extinguishing metal compounds emit visible light. Colors given by barium and calcium and their wavelengths given in the table. Which has the higher energy? Given a reason for your answer. Always good to never lose sight of where these colors come from. They come because you've got emission of different wavelengths of light. And of course, there is the relationship between the wavelength of light, the frequency that we're not interested in, and the energy. And that is for the energy and the wavelength, it's an inverse relationship. So barium has the lower wavelength, thus the higher energy. Barium chloride sulfate, observation expected, talked about this several times. Barium ions floating around, sulfate ions floating around, get together to make solid barium sulfate, which is a white precipitate. Different adjectives I've seen in different exams for this, a white precipitate, but just remember it's got a white precipitate. And that should work for you because it does seem like the descriptions change from one year to the next. Casa Testamines flame test, what the colors, well, you just got to know these: calcium, brick red, and potassium, lilac. Okay, particularly important you remember calcium is brick red because you have strontium and lithium also give you variations of red. So you do need to know the words that the examiners are particularly looking for. 5 beakers, A, B, C, D, E, each contains different solutions. So we've got barium bromide, barium nitrate, calcium chloride, magnesium nitrate, but don't know what ones are in there. You also have silver nitrate, sodium hydroxide, sulfuric acid. So devise a plan to use them to unambiguously determine which solution's in which beaker. So silver nitrate, as said before, the nitrate is irrelevant, but it does make precipitates with halides. We have chloride in here for the calcium chloride and the magnesium chloride, which will give a white precipitate, and we also have bromide in there, which gives you the cream precipitate. Again, without a comparison, not necessarily that easy to determine whether precipitate is white or cream, but this is A-level, so we'll go with it. Sodium hydroxide, of course, is a base, but in this case it is the hydroxide that will give you a precipitate if you have either calcium ions or magnesium ions in there, giving you the white precipitate. Barium hydroxide, however, is soluble, so therefore would not give you a precipitate. And finally, sulfuric acid. Well, of course, anytime you see acid, first thought should be carbonate. We don't have carbonate here, so therefore we'll think about the sulf part, the sulfates. And of course, sulfate will give you a precipitate with calcium or barium, or of course strontium, the heavier alkaline earth metals. So there we are. So our 3 tests are just essentially going to distinguish between different solutions based on the solubility of the particular ionic compounds formed when either silver hydroxide or sulfate go with barium, calcium, magnesium, or bromide or chloride. Nitrates, of course, always spectator ions when it comes to ionic reactions. So let's do these tests. Now, the way I'm doing this is a little bit confusing because I'm doing it with a flowchart, but each time, each test, you go back to the original solution. So anyway, first thing I would do with my solution is I would add silver nitrate, because that can have three possibilities. It could give me a cream precipitate, which would unambiguously identify the presence of barium bromide. Could give me a white precipitate. Now, if there's a white precipitate, then I've got chloride in there, but I have two possible chlorides. So if I see the white precipitate, I'll go back to the solution and add some sulfuric acid, and that will either give me a white precipitate or no precipitate. Now, the two chlorides I had are calcium and magnesium, so the fact that you got the white precipitate with silver nitrate immediately narrows you down to these two. Take the solution, add sulfuric acid, you see the precipitate is calcium sulfate, so that would tell you it's calcium chloride, and no precipitate would tell you it's magnesium chloride, because you already know there's chloride in there from the silver nitrate test. So that's how you identify three of them, the ones with the halides. However, if you don't have halide as the anion, when you add silver nitrate, you would see no precipitate. So now how can you distinguish between these? Well, if you see no precipitate, then that tells you that it's either barium nitrate or magnesium nitrate. So you add sulfuric acid to the solution, knowing it's one of those. If you see a white precipitate, that tells you that it was the barium nitrate, and no precipitate would tell you you have the magnesium nitrate. Okay, so essentially first thing to do would be distinguish based on the silver nitrate, and then the second thing to do would be to add sulfuric acid, and that will help you distinguish between any ambiguities associated with the behavior from the silver nitrate. Now, if you want to, seeing as how they talk about having sodium hydroxide available, you can confirm this no reaction by, if you get the solution and no precipitate with silver nitrate, no precipitate with sulfuric acid, just try adding a little bit of sodium hydroxide to it, because if the solution is indeed magnesium nitrate, then you will get the white precipitate of magnesium hydroxide. So next two questions, somewhat redundant based on what we've done so far, but emphasizing again what the exam board likes. So first of all, test for calcium ions, flame test, brick red flame. Secondly, test, apart from the use of chlorine, to show bromine solution contains bromide. Again, add silver nitrate, forms a creamy precipitate. If you want to, you could then take that creamy precipitate and observe that it doesn't dissolve back in dilute ammonia, but does dissolve in concentrated ammonia solution. But ammonia solution is a bit stinky, so I would just be happy with the cream precipitate. Solid potassium iodide reacts with conc sulfuric in the same way as sodium iodide could show. Describe the observations made during this reaction and identify the products formed. So first thing is, there's the potassium iodide with sulfuric acid, makes the potassium hydrogen sulfate plus hydrogen iodide. Hydrogen iodide itself then reacts further with sulfuric acid to give you iodine, SO2 and water. And as you make the IO2, hydrogen iodide reacts with it to make H2S and iodine and H2O. So you're going to see iodine, water, SO2 and H2S. Okay, iodine in solution gives you a purpley brown solution. H2S stinks of rotten eggs. You don't want to do this on the bench top. And SO2, a choking acrid smell. Really don't know why they talk about this at A-level, because you don't want to be generating H2S and you really don't want to be generating SO2. So hopefully there's no schools around where you actually do this reaction. But anyway, there you go. You can tell for iodide, if you don't want to just make the yellow precipitate with silver nitrate, if all you've got floating around is conc sulfuric acid, you can test for iodide by making the purpley brown solution, rotten egg smell, and the choking acrid smell. Aqueous iodide ions added to a aqueous solution of lead nitrate, precipitates formed. Color of the precipitate, well, of course, it's going to be lead plus iodide, makes the insoluble lead iodide. Remember, chloride, bromide, and iodide have insoluble silver, lead, and copper plus. And this particular lead iodide is a yellow solid.